There's some things you just have to see to believe. On camera, these images created by the Photon League look flat and two-dimensional, but in person, they are realistic 3D, appearing to actually occupy the space in front and behind the flat canvas they're imprinted on. This lab was created in the 1980s by graduates of OCAD University. Today, it is among the world's most well-equipped hologram production facilities. Thanks to shows like Star Trek, we're all familiar with holography, but what is it exactly? I asked Michael Page, an assistant professor at OCAD and an expert in 3D visualization with 30 years of experience.
In the basic hologram, you're seeing this incredibly accurate, although in some cases monochromatic, rendition of that object as it looked under laser light when the hologram was created. So you've actually captured that waveform in a way that says to your brain that that object is there.
Tucked away in a basement here in downtown Toronto, I'm standing in the Photon League's laboratory, and behind me is a ruby laser machine. It creates an intensely powerful laser that apparently could beam through the walls of this building, yet they only turn it on for a very short time period, something like 10 billionths of a second, to create a freeze frame image that they use to create some of the holograms that we're seeing today. While these holograms may look real, you can't grasp them. They are intangible, but Page hopes to change all of that with the help of some federal funding. Page will be working on a cutting-edge new project with Waterloo, Ontario-based Intact Robotics. That company specializes in using robotics to create haptic feedback. That means providing tactile feedback, like when your video game controller shakes, or when you get a touchscreen phone that vibrates when you press a button. Combining robotics with holograms, the hope is to literally create holograms that you can feel.
We're going to add another construct to that environment in the form of a holographic projection. And the way that digital holography works is that we create a 3D construct in your favorite 3D animation software. We use 3D Studio Max, and you describe that environment in terms of objects, when you do a simulation at least, in terms of objects that are soft, objects that are hard, objects that are movable. And then what you do is you translate that map, if you will, into another 3D construct that describes the position and relative rigidity or softness of these objects in three-dimensional space. So the same 3D information that goes to make the holographic construct will be mapped into the haptic construct, and when you superimpose those things, you ought to be able to touch that thing which is otherwise ethereal and can't be touched.
Not only will you be able to feel this hologram, but it will appear to change as a result of your interactions with it. Holograms in the Photon League lab are animated by light moving across them, or by a change in the perspective of the viewer. This simple effect allows for a giant robot head to emerge out of Los Angeles in this poster, or for an alien's eyes to appear to follow you around the room in this poster. Alright, so you're taking all of these elements, animation, haptic feedback device, and a hologram that you're projecting, and you're going to create some sort of prototype that I understand will assist medical students learn how to perform surgeries. You want to describe what that prototype will entail?
Sure. I think we're going to build a number of prototypes. I think the medical prototype is readily understood. And essentially what we're going to try to create is an augmented reality environment for people to be holding this haptic device from Intact Robotics, and you'll look through the holographic layer and see your hand holding a scalpel, and the holographic construct of a human torso, which would look more like a visible man or something, and that user will be able to, with a scalpel, cut through the epidural layer and feel that physically, and then be able to feel the soft tissue and what bone feels like when you hit it with a scalpel and that sort of thing. And we're hoping that that experience will be something that assists emerging surgeons, doctors in learning how to do these critical procedures.
Page hints that there could be other applications for haptic holography, including a new way to experience video games. You could imagine a lot of reasons you might want to create the illusion of something that isn't really there. After all, Seeing is believing. For itbusiness.ca, I'm Brian Jackson.